Hi everyone, welcome to the second session of Unit 8 Redox Reactions plus 1 Chemistry. In the last session we discussed about types of redox reaction. So today we will focus on how to balance a redox reaction. There are mainly two methods to balance redox reaction. One is the oxidation number method and the other one is half reaction method or ion electron method. So today in this session we will discuss how to balance a redox reaction using oxidation number method. Let us see the first question. So this reaction is an acidic medium. So the first step is to rewrite the skeletal equation. The next step, calculate the oxidation number of each atom in the equation. The oxidation number for copper is 0 since it is in the free state. Then for hydrogen it is +1 and oxygen is -2 and we do not know the oxidation state of nitrogen. So let us take it as x. So we have 1 plus x plus -2 into 3 is equal to 0. So we will get 1 plus x minus 6 is equal to 0 and x is equal to +5. Then Cu2 plus, it is a monoatomic ion. So the oxidation state is equal to the charge, that is +2. Then NO2, oxygen it is -2. So we do not know the oxidation state of nitrogen. Let us take it as x, x plus -2 into 2, altogether it is equal to 0. So x minus 4 is equal to 0, x is equal to +4. So that is Cu plus HNO3 gives Cu2 plus NO2. Here copper is 0, nitrogen is +5, Cu is +2 and here the nitrogen is +4. Now let us identify the elements which undergoes a change in oxidation number. That is Cu0 becomes +2 and here +5 becomes +4. So here the change in oxidation number is change in ON is equal to 0 becomes +2, that is 2 is the change in ON here, and here it is +5 becomes +4. So change in ON is equal to 1. In the next step you have to make the change equal by multiplying with a coefficient. So you can see that here it is 2 and here it is 1. We can make this 1 2 by multiplying with 2. That is 1 into 2 is equal to 2. Then the reaction becomes Cu plus 2HNO3 gives Cu2 plus 2NO2. So now you can see that we have balanced all elements except oxygen and hydrogen. Now let us balance oxygen and hydrogen. Here you can see that this side we have 3 into 2, that is 6 oxygen atoms, and here we have 4 oxygen atoms. So where there is a deficiency of oxygen atom, there we can add water molecules. So here let us add 2 water molecules. Now oxygen is balanced. Now let us balance the number of hydrogen atoms. Here we have 2 hydrogen atoms and here we have 4 hydrogen atoms. So there is a deficiency of 2 hydrogen atoms here. So to balance the number of hydrogen atom, let us add H plus ions. Now this reaction is balanced. Next question. So this reaction is also in acidic medium. Rewrite the skeletal equation. Calculate the oxidation state. Here we have 2 chromium atoms. So we will take it as 2x. Oxygen, we have studied that is -2. So let us calculate 2x plus -2 into 7. Altogether it is equal to -2. For polyatomic ions, the sum of the oxidation state is equal to the charge possessed by the ion. Here it is Cr2O7 2 minus. So altogether it is equal to -2. So 2x minus 14 is equal to -2 and 2x is equal to 12 and x is equal to 12 by 2 is equal to plus 6. Then here we do not know the oxidation state of sulfur and oxygen it is -2. So let us calculate x plus -2 into 3 is equal to -2, x minus 6 is equal to -2 and x is equal to plus 4. Then chromium is a monatomic ion, so the oxidation state is equal to the charge possessed by this ion, that is plus 3. Then here also we do not know the oxidation state of sulfur. Oxygen it is -2, so x plus -2 into 4 is equal to -2. So x minus 8 is equal to -2 and x is equal to plus 6. So the reaction is Cr2O7 2 minus plus SO3 2 minus gives Cr3 plus SO4 2 minus. Now let us identify the elements which undergoes a change in oxidation number. So here you can see that chromium, in this reaction we have 2 chromium atoms here, but this side we have only 1 chromium atom. So add 2 here. Then the oxidation state of one single chromium is plus 6. Since here we have 2 chromium atom, it is plus 12. Then sulfur, it is plus 4, and here the oxidation state of Cr3 plus is plus 3. Since we have 2 Cr3 plus ions, we will write plus 6. Then here the sulfur is plus 6. So chromium plus 12 becomes plus 6. Change in ion is equal to 6. Here sulfur plus 4 becomes plus 6. Change in ion is equal to 2. So make the changes equal by multiplying with a coefficient. Here you can see that the change is 6, here it is 2. So we can make this 2 6 by multiplying into 3. So the reaction becomes Cr2O7 2 minus plus 3SO3 2 minus 2Cr3 plus 3SO4 2 minus. So this 3 is added to both sides. So now we have balanced all elements except oxygen and hydrogen. So next step is to balance oxygen and hydrogen. So count the number of oxygen atoms. Here we have 7 plus 3 3s are 9, that is 9 plus 7 16 oxygen atoms, and this side we have 12 oxygen atoms. So this side there is a deficiency of 4 oxygen atoms. There let us add 4 water molecules plus 4 water molecules. Now let us balance hydrogen atoms. So this side we do not have any hydrogen atoms, and here we have 8 hydrogen atoms. So, in order to balance hydrogen atom, we will add 8H plus to the side deficient of hydrogen atom. So, now this reaction is balanced. Next question. MnO4 minus plus Br minus gives so this reaction is in basic medium. Write the skeletal equation, that is MnO4 minus plus Br minus gives MnO2 plus BrO3 minus. Calculate the oxidation state of each atom. So, we do not know the oxidation state of manganese, let it be X. Oxygen is minus 2, so it is X plus minus 2 into 4, altogether it is minus 1 since it is polyatomic ion. So, X minus 8 is equal to minus 1, X is equal to plus 7. Then bromine is a monoatomic ion, so its oxidation state is equal to the charge minus 1. Then here we do not know the oxidation state of manganese, let us take it as X, oxygen is minus 2, so X plus minus 2 into 2 is equal to 0 since it is neutral. So, X minus 4 is equal to 0 and X is equal to plus 4. Then BrO3 minus, we do not know the oxidation state of bromine and oxygen is minus 2, X plus minus 2 into 3 is equal to minus 1. X minus 6 is equal to minus 1. So, X is equal to plus 5. So, identify the elements which undergoes a change in oxidation number. So, here we can see that manganese is plus 7, bromine is minus 1, this manganese is plus 4 and here the bromine is plus 5. Plus 7 becomes plus 4. Change in ion is equal to 3. Minus 1 becomes plus 5. So, here we have minus 1 to plus 5. So, we have 0, 1, 2, 3, 4, 5. So, the change in ion is equal to 6. Now, let us make the changes equal by multiplying with a coefficient. Here it is 3 and here it is 6. In order to make the change equal, multiply 3 into 2, it becomes 6. So, now the reaction becomes 2 MnO4 minus plus Br minus gives 2 MnO2 plus BrO3 minus. Now, let us balance the negative charges. Since it is basic medium, there is a slight change in this step. Now, we are going to balance the negative charges. See, here we have altogether 3 negative charges, that is 2 MnO4 minus ions and 1 Br minus ion. So, altogether here we have 3 negative ions and this side we have only 1 negative ion, that is BrO3 minus. So, in order to balance the magnitude of negative charges, we can add OH minus ions where there is a deficiency of negative charge. So, here let us add 2 OH minus. Now, let us balance the oxygen and hydrogen atom by adding water molecules. So, here we have 8 oxygen atoms and this side altogether we have 9 oxygen atoms. So, there is a deficiency of oxygen atom this side. Here let us add one water molecule. So, by adding water molecule here we have balanced both hydrogen as well as oxygen atoms. So, thus this reaction is balanced. So, let me conclude. Today we studied how to balance a redox reaction using oxidation number method. Thank you.